Hello, welcome to an edition of Visualizations with JUCE. Today we're going to look at building XY pads. These two-dimensional control surfaces where you can control two or more parameters at the same time. We're basically mapping the x-axis of the pad to one set of controls and the y-axis to another set of controls. We're going to build this such that you can assign or register an arbitrary number of controls to a particular axis of the XY pad, and then deregister it when you don't need it anymore. It's quite similar to how it's implemented in Ableton Live, where you can assign any automation parameter of a plugin to one of the axes of the pad. Our implementation will be a standalone JUCE component, which you can bring it into any project that you want, and will also have the ability to assign more than one control to an axis. Before we get into the code though, let's look at how we can design our components and architect our code on a more holistic level. We've got the plugin processor, which deals with the audio backend of the plugin. For the sake of simplicity, we'll do some very simple signal processing here. We'll perform our gain and pan processing, the parameters of which will be controlled by the XY pad. Visually speaking, the gain and pan kind of makes sense here. We can assign the pan to the x-axis, where we can see a visual representation of it moving from left to right. And then we can assign the gain to the y-axis, where you can visually see the increase or decrease of the volume of the track. Anyway, we'll perform our gain and pan processing within the plugin processor, the parameters of which will be controlled by the XY pad. And then we have the plugin editor, which deals with the visual front end of the plugin. The plugin editor has a reference to the processor, and with that has access to the parameters for gain and pan. We can have a couple of sliders here, one that's mapped to the gain parameter, and another one which is mapped to the pan. And then we can have a custom JUCE component that represents an XY pad. The XY pad is basically made up of a background component, which just makes up the surface of the XY pad, and a round thumb component, which represents the draggable point within the surface. Now we need some mechanism to inform the parameters that their values need to change when we move the thumb within the XY pad. There are a couple of ways that I can think of doing this, and one is subjectively better than the other. One way to do this would be to have an event-based approach. We would pass an event denoting that XY pad is moved down the parent hierarchy till the event reaches a component which has all the dependencies that it needs to translate the position of the thumb to slider values. This event can be sent synchronously or asynchronously. I'm not a huge fan of this approach, since the component that has all the required dependencies is the plugin editor. It would then become the responsibility of the plugin editor to listen to events generated by the XY pad, respond to it by translating the position of the XY pad to the value of the slider. And then it would have to do this the other way around as well, listen to slider changes, and then respond to them by translating the value of the slider to the XY pad position. The plugin editor shouldn't be responsible for this sort of low-level orchestration. It should ideally only have to worry about hosting high-level children components and nothing else. A more elegant approach would be to host all of this interaction within the XY pad itself. We can expose an interface within XY pad that lets the caller, in this case the plugin editor, to register a slider to one of the axes of the pad, and then deregister it when not needed. The plugin editor will have to pass the pointers or a reference to the sliders that it owns, and the XY pad will have to manage this collection of slider pointers that it receives. Alright, so this may all sound a bit too abstract, but things will become a lot more clearer once we get into the implementation. Let's get started. I'm going to open up a new ProJuicer project. I'm going to select a basic plugin project for this. I'm going to call it XY Pad. And under modules, I'm going to actually select the JUCE DSP module for later use. Under exporters, I'll select Visual Studio 2019 and Xcode. And then I'll just create a new project. And you can save this where it suits you. Under this project, we'll go into the settings pane, and I'll change a couple of things here. For the company name, I'll change it to Tilt Audio. And I'm going to enable adding using namespace JUCE to the JUCE header file, so that I don't have to explicitly type JUCE and scope resolution operator before referencing any of the JUCE classes. With that done, I can just open the solution. It's going to take a little bit of time to index the project. And once it's done, I'm going to right click on the VST3 project, and I'm going to set it as the default startup project. And then I'm going to go into local Windows debugger, and under that, I'll select the properties, go into the debugging pane, and I'm going to change this command. I'm going to change this to the path of the executable of Reaper. You can choose to put the path to any DAW software that you've installed on your computer. I'm going to select OK, and I'm just going to start the project. This is going to take a little bit of time initially to compile the project and run. Once the compilation is done and it runs the code, it'll open up Reaper for me. Over here, I'm going to create a new track and add a VST3 plugin on top of it. I'm going to select the XY pad here. If the XY pad doesn't show up for you, you might need to add a new VST3 search path into your DAW software, and it needs to reference the build directory of your XY pad project. Sweet, so we've just got a bare bones plugin which doesn't really do anything, but we'll start from here. So I'm going to save this project file in Reaper as well. The reason for this is every time a debug build runs, it'll open up Reaper with this configuration, so that I can quickly test the plugin and see if the changes that I've written are valid. Alright, let's close this and let's dig into the code, shall we? All the code is situated within the shared code project. I'm going to twiddle down and go into sources and select plugin processor.h. So the first thing we're going to do is set up the DSP part of it, the gain and the pan processors. If you're not really interested in this part and you really want to actually just check how to build the XY pad instead, you can scroll to the next section on YouTube. Right, so in the plugin processor, we will firstly establish a couple of parameters. And parameters here are going to be the global parameters that are available and exposed for this particular application, namely the gain and the pan parameters. So the best place for you to put these parameters would be within the audio processor value tree state instance. So I'm going to declare a new instance of the APBTS class, and we'll have to initialize this within the constructor. So within the source file and within the constructor, I'm just going to try and reorganize some of this. We don't really need these macros. We know that this is a plugin project which accepts an input and produces an output. We know that this is not a synth, so we can just remove all of this boilerplate so that it becomes a little more cleaner. Once we've done that, we'll initialize the parameters. So the audio processor value tree state class accepts the following arguments. The first one is the reference to the audio processor class itself, so it's just dereferencing this pointer. After that, it asks me for an undo manager, so we don't really need that at the moment, so we'll just pass a null pointer to it. Next is the parent identifier. I'm going to call this XY pad. And finally, it's a parameter layout. And for the parameter layout, you can basically pass and initialize a list of unique pointers of audio parameters, essentially. And you can have plenty of different kinds of audio parameters, but since both gain and pan are going to be floating point values, we'll select audio parameter float for this. So we'll make a unique pointer of audio parameter float. The first parameter will be a unique identifier. The second argument is going to be the name of this parameter. And this is going to be exposed as an automation parameter as well. So this is what will be displayed within the list of automation parameters. So I'll call it pan. Next, we have a normalizable range. So I'm just going to say the pan value goes from -1 to 1 with a really small interval of 0.01. And I'm going to say the default value starts from 0. Similarly, I'm going to create one for gain as well. So I'm just going to copy this and I'll call it gain here. And the range for gain goes from -60 dB full scale to 0 decibels. And I'm going to let the default value be 0 decibels here. Cool, so now that we've got the parameters set up, we can actually focus on implementing the gain and the pan processing. So for this, we're going to leverage the DSP module that we imported earlier. To be quite honest, you don't really need the DSP module for such simple effects like gain and pan. You could just do this by hand, but since this tutorial isn't meant to be anything about gain and pan processing, I'm just going to use the bog standard ones that are defined already. So I'm going to use the gain class within the DSP module. I'm going to call it gain processor. And similarly, I'll use a panner. I'm going to call this pan processor. The DSP processors implement the same methods that are part of the processor base class within the DSP module. All that means is there are 3 methods that you need to call. The prepare method, the reset method, and the process method. So within the prepare to play method in the audio processor class, we'll call the prepare method of the gain processor instance. This accepts something called a process spec. This is nothing but a small enumeration that contains the sample rate, the samples per block, and the number of channels that are configured. So we'll just pass the specification object to the prepare method. We'll do the same for the pan processor. And within release resources, we'll call the reset method of both. So I'm going to clean up a little bit of the is buses layout supported. Again, for the same reason, we don't really need macros here. We'll just make it a little more cleaner. And finally, within the process block method, this is where the bulk of the processing happens. I'm going to delete a lot of this. I'm just going to keep the first line, which is to disable subnormal numbers. And I'm going to call the process method of the gain processor instance. The process method requires a process context. I'm going to create a new process context, and it's going to be a replacing context, meaning that the input and output buffers are shared, so changing one would impact the other. We wouldn't need a non-replacing context, so let's go with this. The context accepts an audio block. So we'll create an audio block. An audio block can be constructed from an audio buffer. The audio block is a pretty inexpensive wrapper around the audio buffer object. It doesn't actually own any of the data, it just acts as a wrapper essentially. With all of this configured, I'm going to pass the context object into the process method. And I'm going to do the same for the pan processor as well. So I've forgotten to set the initial parameters of the gain and the pan processor, so I'm going to just do that now within the prepare to play method. So I'm going to set the gain in decibels of the gain processor, and I can get this value from the APVTS class that we have. So I'm going to say parameters that get a raw parameter value of gain. So that'll give us an atomic of a float, and I'm going to call the load method on that. So another tip for writing less error-prone code is to make these identifiers some sort of static constant values that you can reference across your project. Because if you have a lot of parameters, you kind of tend to get lost with the naming. But over here, it's quite unambiguous, so we just have gain and pan. So I'm not really going to bother setting up static const values for these. For the pan processor, I'm going to set the pan as well to some initial value. Brilliant, so that's done. So now all we need to do is respond to changes when these parameters change. A simple way to do this in the processor itself is by adding a listener to each one of the parameters that we've defined within the audio processor value tree state instance. So I'm going to go back to the header, and I'm going to inherit from a new base class. And this time it's going to be the listener class within the APVTS class. There's a pure virtual function that we need to override, and it's called parameter changed. I'm going to define the parameter changed member here, and I'm going to generate the implementation within the source. Over here, we passed 2 arguments. The first is the parameter ID of the parameter that changed, and the new value that it changed to. So we want to query the parameters here. If the parameter ID is equal to gain, then we set the gain processor's decibel value to the new value. If the parameter changed is the pan parameter, then we set the pan value within the pan processor to the new value. So just doing this isn't enough, so we need to register these parameters that we're interested in listening to. So I'm going to go up to the constructor, And within the body of the constructor, I'm going to say parameters.add parameter listener. And the first parameter will be the gain, and the listener will be this class because we've inherited from APVTS listener class. I'm going to add the parameter listener for pan as well. And since we're all good boys and girls here, we need to remove the parameter listener from within the destructor. So I'm going to go into the destructor. I'm going to say parameters.remove parameter listener for both gain and pan. Now that we've completely set up the processor side of it, we'll go into the editor and we'll set up a couple of sliders so that we can control the gain and the pan parameters. So I'm going to go into the header file of the plugin editor. I'm going to create a new slider. I'm going to call it gain slider. And I'm going to initialize the slider to be a rotary slider with either horizontal or vertical drag. And I'm going to say the text box should be below the slider. These are all cosmetics. You can change it to whatever you want it to be. And I'm going to replicate the same configuration for the pan slider as well. And an easy way to maintain state between the processor and the editor is to leverage the audio processor value tree states slider attachment. This is a great little tool for making sure that there's synchronicity between the editor and the processor. The value of the gain or the pan parameters could change either directly from the editor where the user moves the slider, or it can change from some automation curve that the user has defined. Either way, it'll be reflected in both the processor and the editor, which is great. So that's what we need to do. We need to attach these sliders to the audio processor value tree state parameters. To do that, we're going to leverage the slider attachment class within the audio processor value tree state. Now it's already quite a mouthful, so I'm going to use a type def here, or a using declaration. I'm going to simplify this to just slider attachment. I'm going to create a couple of labels as well, just to label the sliders. One for the gain label, and one for the pan label. The slider attachments would need to be configured within the constructor, so let's initialize them here. Quickly we see that it needs a reference to the audio processor value tree state. So what we'll do is go to the plugin processor and set up a getter method for getting a reference to the audio processor value tree state class. So I'm going to call this get APVTS, and this simple getter method which returns the parameters object that we have. And within the editor's constructor, I can reference the processor objects get APVTS, and the identifier of this parameter, as we know, as gain, and we're going to attach it to the gain slider component. We'll do the same thing with the pan attachment as well. So to display a slider, or any component for that matter, we need to do two things. One, we need to add and make visible the component that we need to display. So this will just add the component as a child and set its visibility to true. So we'll add the gain, the gain slider, the pan slider, the gain label, and the pan label. For the gain label and the pan label, we'll set the justification to centered. And for both these labels, we'll attach them to their corresponding components. So we can say gain label will attach to component, and we'll attach it to the gain slider. It asks me, should it be on the left? If you say false, it'll put it on the bottom of the slider. Or the top of the slider, I'm sorry. It's very confusing, right? So it's not written all that well, to be honest. What if you want it on the right side or the bottom of the component? You can't. It's a shame. Anyway, within the paint method, we don't really need any of this. So we'll clear out a lot of this. We'll just retain the statement that fills the background color. And the second thing we need to do to visualize any component is to set its bounds. So the bounds of the parent component are available within the resize method. So within the resize method, we'll set the gain slider's bounds. I'll create a local variable for this. And we're going to cut off half of the total bounds for the gain slider, and the rest of the half can be for the pan slider. Brilliant. So if you've written everything correctly, we should be able to run this and test out a new plugin. Alright, so we've got a couple of sliders here called gain and pan, and it's responsive and all of that jazz. So just to test it out, I'm going to drop an audio file into the track and we can hear the difference that the plugin makes. Now let's get into the meat and bones of this project. We'll create the XY pad now. So I'm going to go into the ProJuicer project. I'm going to create a new group here. I'm going to call it component. And within the component directory, I'm going to create a new pair of files, a header and a source file. I'm going to call this XY pad. I'll save the ProJuicer project and Visual Studio will prompt me to reload the project. The new files should be available within the component directory. And clear out a few things, and I'm going to include the JUCE header here. So I'm going to declare a new namespace here for all GUI components. Within the GUI namespace, we're going to have a class called XY Pad. And this class will inherit from JUCE's component class. So XY Pad will be our custom JUCE component here. Brilliant. Now let's just think about what methods we may need here. So we're going to need the constructor. I'm going to define a constructor here. And we probably will have to override the resize method and the paint method. So I'm going to define them here. What else do we need to do? We might need to register a slider, right? So within the editor, we might have to say, well, you've got an instance of an XY pad. What should the XY pad be concerned with? So we can register a few sliders within the XY pad. So we'll expose a method here called register slider. So what would it need to accept? So it would probably need to accept a pointer to a slider. This is a raw pointer that we're accepting. That's perfectly fine since we're not going to be owning the raw pointer. So the XY pad will just need to have a reference to this slider. It doesn't need to own this slider. And we also need to have some context about which axis of the XY pad is this particular slider referencing. So should the XY pad move sideways from the x-axis when the slider moves, or up and down on the y-axis when the slider moves? So we want to define some sort of enumeration for the axis. So I'm going to create a new enum class called axis with just two values, x and y. Now, since we're registering this slider, we need a mechanism to deregister the slider as well. So we're going to put that here. I'm going to say deregister, and we're going to accept a pointer to a slider like before. We don't need the axis context here because we can just go ahead and search for the slider and delete it from wherever necessary. So now we've got an interface for registering a slider and deregistering a slider. So we need to have a collection of registered sliders, right? We'll create a new vector of slider pointers. And we're going to have two vectors. One for the x-axis called x sliders and one for the y-axis called y sliders. And I'm going to add a macro here. It's called JUCE declare non-copyable with leak detector. This is sort of like a nice to have within custom JUCE components. It's got a built-in leak detector, so if somebody creates a new raw instance of the XY pad somewhere and forgets to delete it, the developer will get informed that there's a leak. And it declares this particular class, the XY pad, as non-copyable and non-movable, essentially. And this is not something that you can control yourself because the parent class, which is the component class, itself is non-copyable and non-movable. So even if you wanted to have movability or copyability of your new custom component, you can't. So it's nice to just put this macro here. What else do we need? So we've got the base of the XY pad sort of configured, right? Oh, but we're missing one critical component. The thumb slider, the little thing that we need to click on to move within the XY pad. So I'm going to create a new class to represent this. I'm going to call this class thumb, and it's going to be a public class within the XY pad class. So within this thumb class, what do we need to do, right? So we need to maybe just have a constructor, and we might want to override the paint method. We probably don't really need to resize anything because it doesn't really have any children. That's enough, I guess. And I'll just drop the same macro that we used previously here as well. Now we can start implementing these methods. Firstly, I'm going to go into the source file and I'm going to declare the namespace here. And I'm going to go back to the header file and I'm going to say generate implementations for all of the methods that don't have an implementation yet. So this is a feature of ReSharper that I use from JetBrains. It's pretty cool. If you don't have that, you might have to manually implement these methods. It's sort of given us skeleton implementations of these methods. Let's work on the XY pad itself. Firstly, I'm going to have to add and make visible the thumb component. I've forgotten to create a new instance of the thumb class. We've declared a thumb class. We don't have an instance within its parent. So let's go ahead and create an instance of a thumb within the XY pad. And we're going to go back to the source and yes, we'll add and make visible this thumb component. And we'll set its bounds. So we're going to say thumb component.setBounds. We can just set it at the center for now. So we can say get local bounds with size keeping center is a method within it, which will give us a new rectangle with its origin or its center point as the center point of the parent. And we can give it some dimensions. I want to say the thumb can be around 40 pixels wide and 40 pixels in height. We might have to use this thumb size elsewhere, so let's declare this as a static const expo called thumb size, and we'll set it to 40. And within the paint method, we don't really need to do anything fancy here. We'll set the background color of the XY pad as black, let's say, and we'll fill a rounded rectangle with a corner radius of about 10 pixels. Now let's go to the thumb section. We don't really have anything to initialize here, so we're just gonna leave the constructor empty for now. Within the repaint method, how should the thumb look, right? So it should be circular. So we'll just assume that whoever is calling the setBounds method on the thumb will make sure to set it as a square bounds rather than a rectangular bounds. So we'll set the thumb color as white, let's say, and we'll fill an ellipse of the local bounds. Well, this is enough for now, I think. Let's just see how it looks so far. So I'm going to go into the plugin editor and we'll bring in the XY pad custom component here. The first thing I'm going to do is include the XY pad component and then create a new instance of the XY pad. Within the constructor, I'm going to add and make visible this component. And within the resized method, I'm going to have to set its bounds. But before that, I'm just going to set the overall size a little wider to 500 pixels. Over here in the resized method, I need to set the bounds of the XY slider. But I also need to know the total width of the component. I'm going to create a new constant bound here, call it container. So the container will be the container of the parent reduced by 20 pixels, and this is going to be constant. And the bounds is essentially a copy of the container that we're going to try and slice portions away to each one of the components. So I'm going to change the proportions that go to each of the components. So the gain slider and the pan slider can get 25% of the total width of the component. So I'm going to say a proportion of width of 0.25. Now the XY pad can get half the real estate. So I'm going to say a proportion of width of 0.5. And the rest of it, the rest of the 25% of the plugin real estate can go to the pan slider. Now let's just build the project and see where we're at. Looks alright, doesn't it? So it's got a bit of an XY pad here. Obviously it doesn't move because we haven't really given it any functionality for it to move. It's just a tiny white dot sitting in the middle of the XY pad. So we're gonna try and make this move next. And also we can see that plugin itself is not resizable, so we're going to change that really quickly. So we'll go back into the project and we'll say set resizable on the plugin editor to true and true. So it allows the host to resize it as well, and it allows you to click on the bottom right corner to resize it as well. Now the resizable plugin situation is sorted. Now we need to make the thumb component draggable. This is really easy to achieve. JUCE has given us quite an easy interface for achieving this. So we'll go into the XY pad now, and we'll create a couple of member variables here. The first one is going to be a component dragger. We'll call it dragger. And the second one is going to be a component's bounds constrainer. We'll call it constrainer. Obviously, these are not names from a dictionary, so Visual Studio is telling me, hey, probably got a typo here. But we shall ignore that and continue on. So the component dragger is a class that will allow you to drag this particular component within its parent. It has a pretty easy interface that we'll see in a while for doing this, and the class essentially will take care of the repositioning and the repainting of the component whenever the user intends to move this component. Now the constrainer can be thought of as a little boundary that you can establish within the parent, beyond which you wouldn't be able to drag this component out of. So without the constrainer, you can easily move this component outside the bounds of the parent and it'll just disappear outside the XY pad and you won't be able to get it back. So we want to avoid that, and we want to just constrain it so that the XY pad thumb doesn't move out of the XY pad. I'm also going to override a couple of mouse listener members, including mouse down and mouse drag. We're going to need these two a little later. So to configure the constrainer, in the constructor, we're just going to say constrainer.setMinimum on-screen amounts. This is a bit of a convoluted name for a method. But what it essentially has you do is you need to set the values by which the component is allowed to go off screen. But explained in another way, it's just these values that you need to pass here indicates how many pixels should remain on the screen when the component is dragged off one of the parent's edges. So we know that the size of the thumb is about 40 pixels, and we know that the thumb should entirely remain within the parent. So based on this assertion, we can say that 40 pixels should remain within the screen when the component is dragged out of its parent's bounds. So we can set the minimum value that should remain on all four sides. But all four sides should be 40 pixels, or the const expr that we've declared as thumb size. So once we've got the dragger and the constrainer, we also need to override some of the mouse listener methods, namely the mouse down method and the mouse drag method. These are the two methods where you'd possibly need to inform the dragger class that something is happening. So when the mouse is pressed down, we need to inform that something's happening, somebody's pressed on the component so that it can register. And when the mouse is being dragged while it's being pressed on, we want to inform the dragger here as well that movement is happening. Alright, so within the mouse down method, we're going to call the start dragging component method within the dragger class. We're going to pass the component that the mouse is being pressed on, and we're also going to propagate the mouse event. Similarly, within the mouse drag method, we're going to call the drag component method of the component dragger class. We're going to pass this pointer, the mouse event, and the constrainer that we've defined earlier. Alright, let's check it out. Let's see what we've got. One, it's resizable. That's great. So it maintains some proportionality. And two, we can actually move this thumb around. And we can see even if we go outside the boundary of the parent, well, it still sticks to within the parent's boundary edges. This is great. This is what we needed. Now all we need to do is hook up these sliders so that when the XY pad thumb position changes, the sliders are informed of this change and are synced to the position of the XY pad. So where do we start? The obvious place to start would be in the registration section of the slider. So inside the register slider, let's query the axis. If it's the x-axis that we want to register this slider to, then we'll push this slider pointer into the X sliders collection. If it's the Y-axis, then we'll push it back into the Y sliders vector. And that's really it. Let's look at the deregister slider method now. All we need to do over here is remove the slider from the vector. The slider could either be in the X sliders or the Y sliders collection, or it could be in neither. So we need to handle all of these cases. But think about how you need to remove an element from the vector in the first place, right? A general strategy for removing elements from a vector is to use something called the remove erase idiom. The remove erase idiom is generally used with the STL library. We use the remove algorithm first of all from the standard template library. This accepts the begin and end positions of the vector. So this is going to be the complete vector that we're dealing with. And the third argument is the element that you want to remove. And we want to say sliders. Now, this particular algorithm isn't actually removing anything. What it actually does is give you an iterator. Okay, what iterator does it give? The std remove algorithm is sort of like a filter and sort algorithm. What it actually does is it goes through the range that is specified within this collection and then finds all sliders that doesn't match the filter term that we've given here. All the sliders that are not this particular slider are moved to the front of the collection. And any slider that matches the slider that we've provided here will be moved to the end of the collection. So you're sorting the collection of sorts. And then it'll give you an iterator to the position of where this filtered slider is within the collection. And then you pass this iterator into the erase method of the vector class. Now this accepts the iterator and also it accepts an endpoint. So we're going to remove all elements that start from wherever the std remove iterator points to the end of the vector itself. Seems a bit complicated and cumbersome, but it covers plenty of edge cases as well. So let's say there are plenty of sliders that you registered which were the same slider. So you've registered one slider many number of times. Once you deregister that slider, it'll remove all of the many duplicated registrations as well. Let's say you've not registered a slider and you deregister that slider, then std remove will point to the end of the vector. When you try to erase a vector from the end position to the end position, there is nothing to erase, so it doesn't really erase anything. Once you use this idiom and once you get used to seeing this, it makes everything very compact, easy to understand, and you're making your intention quite clear by using the remove erase idiom here, so that anybody else who's aware of this idiom knows exactly what's happening. Now we'll do the exact same for the Y sliders as well. Now if you're a keen observer, you might have noticed that there are two methods, register slider and deregister slider, which are operating on a shared data structure. X sliders and Y sliders are both vectors, collections that are shared within this instance. Now, whenever you try to add something while something is being deleted, there could be problems. So the obvious thing to do now would be to implement some sort of lock so that when you're registering a slider, the deregistration can't happen. So you have to make sure that your collections are not being read and written to at the same time. If you've dealt with audio programming before, then you might be wondering, well, wait a minute, locking might not be the way to go. You want lock-free programming and all of that jazz. But you've got to remember here, is we're not dealing with the audio thread. This is the message thread. You can lock this without a lot of consequences. Just make sure that you use some sort of scoped lock or an RAII lock, so that it relinquishes control of the lock as soon as you're done with using that method. And make sure not to lock multiple resources that might have contention with other methods. For the lock, one of the things that we can use from the JUCE library is the scoped lock class and the critical section mutex class. But you can achieve pretty much the same thing from within the standard library. We're going to use lock guards and mutex. In the header, I'm going to create a new mutex object. If you've ever done any multi-threaded programming, then you're probably aware of this. mutex is a portmanteau of mutually exclusive. It's a very basic synchronization primitive that's used in programming languages. And it's a mechanism to enforce limits on access to a resource, the vectors in this case, when there are many threads executing and using this resource. So I'm just going to call this vector mutex. And within the register slider method, so I'm going to instantiate a new lockguard class. I'm going to pass the vector mutex within it. So I'm going to do the same thing in the deregister slider method. So whenever a section of the code holds on to this vector mutex, or locks it in this case, no other section which requires the mutex as well can execute. It'll have to wait till whatever piece of code that's using the resource frees it up or unlocks before it can actually go ahead and use it. So the lockguard class is an RAII class, meaning it's a scoped lock. As soon as it loses scope, meaning as soon as the method ends and the lockguard object goes out of scope, its destructor is called, and it's the responsibility of the destructor to release any locks that it may have on the mutex. So all we need to remember now is wherever we're going to access the X and Y sliders, we need to lock that method, or at least lock that scope of usage. Now that we have mechanisms to register and deregister a slider, let's see how we can map the movement of the thumb slider to change the value of the slider itself. Where is the movement of the thumb slider immediately known? Which class has the most knowledge about what happens to the thumb slider? Well, it's the thumb class itself. Whenever you click on the thumb and move it around, the mouse drag method gets called. So ideally, if you can put logic here within the mouse drag method, it would be perfect because, well, that's the place that we are notified that the thumb is being dragged. But the vectors are not present within the thumb class, right? The vectors are present in the parent class. The X sliders and the Y slider vectors are present within the XY pad, which the thumb doesn't really have access to. And the thumb should really not be changing and manipulating the vectors themselves because it's not really the responsibility of the thumb to change the slider values that the parent maintains. So we need some sort of callback method that the parent can pass so that whenever the thumb is moved, the callback method is executed. This way, the thumb doesn't need to know what happens. It just needs to know that there's a callback that needs to be called, but it doesn't really need to understand any technicalities of the callback itself. So what we can do here is create a function pointer or a functor, maybe. I'm not entirely sure if that's the right term, but I've heard it used before. But technically, it's a standard function that we declare. And this function will return void and it will accept a point. This point is the position, the XY position of the thumb itself. So the signature of the method that the thumb class will accept is a function which returns void and a function which accepts a position parameter. Now the thumb is perfectly capable of providing its own position. Now, whoever passes this function pointer, a signature to this function, to move callback, will utilize this point, this position, and do something with it. Let's utilize the move callback within the thumb class itself. So where do we need to call back this callback function? So we need to do it whenever the mouse is dragged. I'm going to say if move callback, meaning if it's initialized to some pointer to a function, then execute this callback. So we'll just say move callback with parentheses, and we will pass the position of this thumb itself. I'm going to go ahead and change the position from int precision to double precision, just because we need to do it later. We need it in double. So I'm going to change this to get position and cast it to double. Brilliant. Now in the XY pad, in the parent of the thumb, we need to define what should happen when the thumb moves. We need to initialize move callback to some function. Over here, we're going to make use of a lambda, an anonymous function. Within the constructor, we will initialize thumb's move callback to a function pointer or lambda. Within the lambda, we're going to iterate through the list of sliders that we have. We'll work with the X sliders first. So we'll use a range-based for loop. We'll iterate through each one of the slider within X sliders. And for the slider itself, we will set its value to something. Okay, so what do we set this value to? Before anything else, let's take a look on the mutex object, because we are actually accessing the vectors here. So I'm going to use the lock guard. Now, what value do we need to set to the slider? If the position of the thumb is all the way to the left, we can treat this as the minimum slider value. And if the thumb is all the way to the right, then we can treat this as the maximum slider value possible. Right, so let's map using JMap the X position that we get from a value of 0, which is the leftmost position, to a value of the width of the XY pad. But what we are dealing with here is the top left position of the thumb. We need to keep that in mind when we're doing these calculations. If we are using the top left position, all the way to the right would be the entire width minus the size of the thumb itself. We want to say bounds.getWidth minus the size of the thumb. And we're going to map this from the minimum value that the slider can hold to the maximum value that the slider can hold. Now all we need to do is do the same for the Y sliders. This time, we are looking at the Y coordinate of the thumb. And the Y coordinate is all the way at the bottom, which is the maximum height of the container. We want to say that the slider value is the least that it can be. And when it's all the way up top, which the position will be 0 for, we want to say that it maps to the highest or the maximum value of the slider. We'll put the same principle here and we'll complete this function. This is it. This is the callback lambda that we have defined. And once we pass this callback into the thumb instance, then it will save this callback. Whenever the mouse is being dragged, it will execute this callback function with the position that it's currently at. And then every time it gets executed, the slider positions will change based on the XY coordinates of the thumb. With that being done, we'll head over to the plugin editor. Over here, all we need to do is register the sliders. So we'll say xypad.register slider. We'll register the gain slider to the y-axis. And we'll register the pan slider to the x-axis. And as I mentioned before, we'll deregister these sliders in the destructor. Wonderful. It's behaving as expected. Moving the thumb left to right moves the pan, and moving the slider up and down moves the gain. Now, you can leave the implementation right here if you want to, right? It's quite complete. But you can go that extra step and change the thumb position itself when the gain or the pan slider changes. So to respond to changes within a slider, we need to listen to that slider. Fortunately, we hold a reference to the slider when we're registering the slider. We can easily call the addListener method of this particular slider, and then we can pass a listener to this. We need to make the XY pad itself the listener so that the XY pad can get notified when a slider changes. So quite simply, I'm going to go into the header file. I'm going to inherit from the slider's listener class. So the slider listener class has a pure virtual function that we need to override, and it's called slider value changed. And I'm going to move that into the private section. We're going to try and implement the slider value changed method. But before that, we'll add the XY pad as a listener to this particular slider when we're registering that slider. And in the deregister slider method, we're going to remove the slider listener. So within the slider value changed method, we need to first of all avoid a loopback. Every time a thumb moves, not only do we set the value of that slider, but because we have set the value of the slider value changed method will be triggered. And we will do some unnecessary things here which will reposition the thumb. this is sort of like a redundant call here, which is not great. So we want to try and avoid that. I just figured that it's not really a loopback because this is not going to be cyclic. It's not going to be called back over and over again. It's just going to be called once. But still, we want to try and avoid that condition at all. So if the thumb is being dragged currently, when this slider value change method is hit, then we don't really do anything because we've already taken care of that in the callback method. Now we need to figure out if the slider belongs to the X sliders or the Y sliders collection. We're going to use an STL algorithm again. We're going to use find. Find accepts the range, so the begin and the end iterator of the collection itself, and we're going to find the slider within it. If the iterator returned by this find algorithm is not equal to the end of the X sliders collection, then we know that it belongs somewhere within the X sliders. So if it is an X-axis slider, then we'll set the thumb's top left position to some value. Again, we'll use the JMap method to map the values of the slider from the minimum position of the slider to the maximum position of the slider, and we'll map those values to graphical coordinate values. So the set top left position accepts an X and Y position, so we're first setting the X position of this X slider, and the target thumb position will go from 0 to the entire width of the component minus the 40 pixels of the thumb width itself, similar to what we did in the callback function. So that's the X position done. And then we can retain the same Y position that the thumb previously had. If it's not an X-axis slider, then it has to be a Y-axis slider. So we'll set the top left position and specifically change the Y coordinate of the thumb. Over here, the minimum and maximum of the slider are mapped from the bottom to the top of the XY pad. And after this logic is done, we just need to call the repaint method. And we need to call this because we've changed the position of the thumb, and if you're not notifying that this thumb has to be redrawn, you won't find the position to be changed at all. So we need to call the repaint method, which is an asynchronous method which gets called at some point in time. Let's check it out. Let's see how it works. There. So moving the gain slider moves the thumb up and down, and moving the pan slider moves the thumb left to right. Alright, so what do we have left over that we haven't done yet? Perhaps the positioning of the thumb itself. So what you can notice here is if you move the thumb around and then close the actual plugin UI panel itself and then reopen it, it's always positioned to the center of the XY pad. This is not great, right? So we left it at one position. We hope it'll stay in that position when the UI panel reopens, but we find it to be in a different position. And also you can see that it's very glitchy whenever you move the slider or the thumb itself. The other one jumps to a certain position, so which is not a pleasant UI experience. So let's fix this in code. So what's the problem here, right? So the problem is that the entire editor is destroyed once you close the plugin UI panel. The plugin processor is the only one that keeps running in the background. The editor is not needed when you close the panel. The destructor of the editor is called and it's thrown away. So when you restart it, a brand new instance of the plugin editor is instantiated. Now the problem is within the XY pad's resized method. So whenever a new instance of the XY pad is created, and when the resize method is called internally, it'll always set the thumb's position to the center of the parent. We've coded it here. So what we need to do is change it so that it needs to reflect the position that the slider is pointing to. So there lies a couple of problems here. What if there are no sliders registered? So If there are no sliders registered, keep it at the center. We'll still retain this statement here in an event where no sliders are registered. If an X slider is registered, then we can sort of figure out the value of the slider and then change the position of the thumb to correspond to the value of the slider. So first we need to check if the X sliders is not empty. If it's not empty, then we set the top left position of the thumb itself. It seems like we've already done this before. Where have we done this? If you go down below in the slider value changed method, we can actually see that we're setting the thumb position based on the value of the slider. So we can reuse this entire method to position our thumb within the XY pad. So if the X sliders is not empty, then we call the slider value changed method. And now the problem then arises, what if we have more than one slider registered? We can't guarantee that all of the registered sliders for the x-axis will have the same value. So this is a very tricky proposition here and a design consideration in the first place, right? So if multiple sliders registered to an axis, then you can't reliably pick one for the value. A complicated but reliable strategy for something like this would be to save the x and y position of the thumb itself as a value tree, as a non-audio parameter in the APVTS class, in the audio parameter value tree state class. This means that you save the entire state of the plugin, including the x and y position, before it's destroyed and it's saved in the host. And when the plugin UI is recreated, the positional attributes can be recalled and reinstantiated. But for keeping this demo quite simple and concise, we'll just select the first slider from the collection. We'll pick the slider at the index 0. Again, we'll set the Y position now. So if the Y sliders is not empty, then call the slider value change method on the first slider within the Y sliders collection. Let's run the application and see what we get. And as you can see, moving the slider around, closing the UI and reopening the UI ensures that the slider remains where it once was before closing the UI. Pretty cool. And that will be it for this demo. So in the original plugin demo that I showed you, there was ways of registering and deregistering and resetting and all of that. We already have the backend to do all of this. If you want to know how I built these sliders to accept or register by getting this pop-up menu up, then you can find the code for this within GitHub in the description of this video. I hope you enjoyed this one. I'll come out with a few more of these if you guys are interested. Thanks again for watching and sticking by. Please do consider subscribing, it'll help the channel grow. If you're really generous, then you can support me on Patreon as well. I'd like to thank Nick Warhol and Adam Scott for their legendary support on Patreon. And I guess I'll see you guys in another one. Take it easy.